Hello? Okay, this is working. Can you close the door, please? Thanks. Hello, I'm Melanie and I'm here to talk about Eclipse Sirius and how you can use it to build a cloud-based modeling workbench. So, what is Sirius? How many of you already know Sirius? Okay, it's majority, but there is some that doesn't know, so I will just explain the main principles at the beginning. So, Sirius is an Eclipse project which allows you to create easily your own graphical modeling workbench based on your domain-specific language. Sirius is a very active project. It is part of the release train, and so we released one major version each year in June, and the rest of the year we released a maintenance version almost every 2 months. There are more than 10 committers actively working on Sirius. So, what are the main principles for the ones who don't know? First, you define a metamodel thanks to EMF. Then you provide a Sirius configuration to specify the mappings between the different concepts of your DSL and how this should be represented graphically. And it results in a graphical modeler dedicated to your own DSL. The Sirius specifier is in charge of creating the metamodel and the Sirius configuration, and the final result is a workbench dedicated to your end user specific to their own domain and to their own specific language. So first, I just will demonstrate the kind of modeler you can create with Sirius. So I will just switch to the demonstration. What you can see here is the kind of end-user model you will have. So imagine that I have to create a graphical workbench for engineers which have to design robots. So I have defined first my metamodel, as I said, and I create a metamodel which allows me to represent systems. Those systems can be composed by composite processors, data sources, and we can represent also some power output and power input, and we have the capability also to create some flow between the different elements of the system. So after that, I'm creating the generated code. I generate the code with EMF, and I specify my graphical modeler with Sirius, and I obtain this kind of modeler. So, for example, how it works. I'm able, for example, to create a new data source. You see that it appears on my diagram. I can change the name of this data source to front camera, for example. And you see that automatically the SVG file, the SVG representation, the SVG icon changed according to the name of my data source. So now I can create also a flow between my new data source and my GPU. And you saw also that my GPU goes to orange because the capacities does not fit anymore the volume. So I decided to change that by updating the capacity of my GPU to 12, for example. You saw that it goes back to blue. But now imagine that my front camera goes from SD to HD, so I need to, this change the volume, so I need to change the volume of my data source. I update it to 10, for example, and you see that my data source is much bigger now, and we still have the GPU changing its color. So it is possible for the robot engineers to continue to change the volume and the capacity until they have a consistent system. Now, I'm able also with Sirius to create some specific layer. This one, I can see it. Okay. Here. I create a layer which represents the temperature of my system. So you see that my system is too hot, it's red, and I can change the label also to show the temperature I have. So now I know that my system is too hot, so on the palette I have also a new element which is a fan. I'm able to create a new fan, I add it, and my system goes to green. So Now, with Sirius, you can create diagram, but you can also create some other kind of representation. For example, I have some matrix I can create. You can see all the representation you have on your Model Explorer. So this is the one I created. The diagram, I can define also matrix. This one represents the connection between the different elements of my system. I can create also tables. This one represents my different processors. I put it right there. And now I can see at both time my different representation of my system. And if I update again the GPU here to 22, you see that all the representations are changing at the same time. So everything is synchronized. Okay, so the graphical editors are defined by a model which defines the complete structure of the modeling workbench, its behavior, and all the edition and navigation tools you will need. This description of a Sirius modeling workbench is dynamically interpreted by runtime, at runtime within the Eclipse IDE. In the end, your final users will only see the end-user workbench and not the configuration anymore. This is for you when you are developing the tool. And as I said, the workbench structure is defined entirely in this Sirius configuration. So only one file for all your application. Sirius provides by default for each workbench a model explorer and a dashboard editor, which allows you to navigate into the model and to create new semantic elements or new representations. A graphical designer provides also viewpoints, which will be adapted to some user roles or activities. And in the end, these viewpoints will be available and visible in the Model Explorer or from the dashboard. Each viewpoint corresponds to a set of representations, diagrams, table, matrix, trees, which can be completely customized. Then the end user can manage the representation from the dashboard editor, and the definition of a new diagram kind in the Sirius configuration results in a new kind of diagram available for the end user. As I show you in my demonstration, it is possible to provide diagrams, but also tables or matrix. If we go back to diagram, each diagram provides default and optional layers I show you, and the layers are activated from the diagram toolbar. The main point of the Sirius configuration is to specify the mappings. The different kind of mappings that can be defined are node, container, and edge. And in my example, the processor are defined thanks to a node mapping. And so how I do that, when I define a mapping in my Sirius configuration, I have first to declare on which kind of elements of my meta model this mapping applies. So this is what I did when I set the domain class in the Sirius configuration, and it is exactly what you find in your meta model. So in this example, I specify that the processor will be mapped to the processor mapping. And then I have to specify how I find this kind of elements from my model. So here again, the Ecore file is my friend. Here I am telling to Sirius that all the processors, which are system elements, must be represented thanks to the workspace image you saw just before that, which that would be my blue square CPU image. It is also possible to define containers, which will allow us to represent containment relation. Here my system contains different kind of elements, processors, data source, fans, and the Sirius configuration allows also to specify edges. So if we go back to our example, to have a look to the Sirius specification now, I will just close this one. Yes. And make this bigger. So what you can see here is my Sirius project is just over here. You have my Sirius specification, which is my flow.ho design. And what you can find in this file is my viewpoints I defined and some kind of representation. topography matrix table. So if we have a look to the topography diagram, I have a main layer which defines some data source mapping, some processor mapping, and system mapping. We see that there is one description per kind of representation. Now, if I want, for example, to change my system, right now it is represented with a gradient which is light gray, I feel. And now I want to change that because the color is not what my customer wants, so I will change that to light blue, for example. This one. When I save my code design, you see, or not maybe, I'm not sure it changed for you. Okay, light blue is not, is too fade. I will try dark blue. Not black, blue. Okay, so the gradient, okay, no, I forgot to just inactivate my temperature layer. Yeah. Now you see that my diagram, my container, my system is blue. What I want also is to change, for example, the label of my system. Not what I want to see is not only the name, but also I would like to see the weight of my system, for example. That would be in kilogram. And when I save, automatically you see in live what the end workbench will look like. So this is really simple for you to iterate with your customer to make the tool it really needs. We can also specify tools because by default Sirius does not provide anything. You have to specify every tools you will have, every behaviors you would like in your end modeler. So for example, how I create those kind of tools, it's really simple also. I can create new section for my palette. And when I want to create a tool, I have different kind of tool elements. I can create new element in my model. I can create editing tool, for example, direct edit, reconnect. I can open a wizard. I can also copy paste. I can delete elements. So I can define some different section in my palette. I'm able to also create elements in my model, but I'm also able to create some new diagram, some new representation. I could define that I would like some new menus, and I'm able also to define some navigation tools to navigate from diagrams or to another diagram or from a representation to another one. So this is it. Okay, so in this small sample, I show you that it is possible to create diagram, table, matrix, thanks to Sirius, but it is also possible to define trees, sequence diagram, and property views. So, to be sure to get all you need to start with Sirius, we are providing today an all-in-one free bundle, which is named OBEO Designer Community Edition. Another license bundle named Team Edition provides what you will need to create Sirius modeler based on CDO in order to provide real-time collaborative edition to your end users. So this already exists today. And the new one in our family is we will offer soon a cloud platform to deploy your Sirius-based modeler easily as a web application. So as promised, I have now 15 minutes to show you how we do that. It's mostly 15 minutes. So we decided to keep the principles of Sirius because we really love that. And you still have your meta model as an Ecore. You still define the Sirius configuration. And Sirius today provides a runtime for RCP application. The idea now is to not provide an RCP application, but a web application. Your end user, instead of opening Eclipse, will just open their browser and to access your modeling workbench. So how it works. The OBEO cloud platform provides, as expected, as it's a cloud, things backend and frontend. The frontend rely on React components, and you have classical ones, like the one to build pages, forms, buttons. And we are providing more complex ones as model explorer, properties, or diagrams. So the OBEO cloud platform is a proprietary build relying heavily on open source technologies. For example, for the diagram component, on the front-end side, we will rely on Eclipse RCP. The backend provides a classical Spring application, which contains, as previously what you do with your RCP application, your EMF code, your metamodel and edit file that you just generated from your metamodel, your Sirius specification, and so its associated Java services. And the backend provides also a GraphQL API to the front end, and you have some WebSocket connections, so subscriptions. Then we provide a core platform that contains, as a classical Spring backend, anything the front end will need for the React components, a Sirius interpreter to interpret at runtime the Sirius configuration exactly as we did for the RCP application. And so we will be able to provide the different representation according to the definition you did. For example, we can create diagrams. For the diagrams, we will provide an auto-layout computation done entirely from the backend side. We have also an EMF JSON library, which allows us to transform our EMF models to JSON in order to save them to our persistency layer. Here it's PostgreSQL. In my demo, it would be MongoDB, but we don't care really about the database. So to get your existing modeler to the OBEO cloud platform, we just need to specify a classical HO design, nothing change. Then you will have to configure some parts on your web application and just run your server. What it looks like. In the end, the first thing I have to do is to just specify my entry point for my server. So I create, this is a Spring Boot application, a classical one. So I create my Spring application run. Then after that, I need to declare which kind of EMF model I will use. So I define the different provider and adapter factory I will use. So here I want to use the flow metamodel, the one I just showed you in the RCP application. After that, it's quite simple. We need also to define the metamodel. So we would like to provide to our end user in the UI. So what is this is just I'm showing you is in my web application, I will provide the capability to, yes, no, that's the tooltip. I will provide the metamodel, which will be my flow. I will give a capability to my end user to just begin a project with some existing model and another kind of metamodel. As I show you in my diagram, in my architecture diagram, you see that we are using JSON, an EMF to JSON library. We develop it. So this one is helping you to get a JSON resource from an EMF resource. And we use it to get the content from the database. So next, what we will have to do is to define, not this one, the representation you want to provide to your end user. So this is simple. You just need to declare the ODesign file you will use. And as we are using some services in our ODesign, we need to keep these services, these Java services in our Spring application. Just after that, I need to run my server. I already did that for you. And how it looks like now is this. So you can create a new project. I will name it Econ U Robot Projects because I will create robots. I will create a new model. This will be Econ U Robot. I select my metamodel. Here I want to create a flow model. And you will have this kind of representation now. You have the model explorer on your left, some property views here, and here you will have some representation when one will exist. So I'm able to name my system. So I create a robot. Now my system, I would like to see a representation of it, so I will create a topography one, like the one I did before. I create my representation, it appears in my model explorer. At the moment it's empty because there is nothing in my system. So I need to create some element. I create that. For example, I will create a composite processor. This one is here, and you will see it in my diagram also. I can select it from my diagram or my model explorer. I can say that it would be a central unit. I would like also to create inside this one a new child that would be a processor, for example. My processor appears. I can name it also proc. And what I will do after that is, for example, I could create another kind of element that I did before. I can create a new fan. My fan does not appear in the diagram. This is normal. It is in my model explorer. So why it's not on my diagram? Because just now my whole design does not show the fan in this kind of view. So what I have to do now is to go back to my, if I can find my mouse, yeah. I go back to my definition. I just stop my server right now. And my whole design is here. It's exactly the same as the one I show you in the RCP application. So what I will do now is I want to represent my fan, so I will just copy my fan, put it in my layer, save. And I would like also to change my system label as I did before. And now I would like to see the temperature also, so I had that. Okay, I save. I just need to relaunch my server, please. Okay, some minutes, or some seconds in fact. So it's home. If I go back now to my page, I need to reload it as I just stopped the server. And now if I open again my element, you see that now I have my fan in. So exactly what you did with the RCP application, you can do the same with the web one. What else? Not this one. What I could do also is I can create some containers, as I show you. I can create some nodes, but the most important thing for us is to be compliant with EMF, as already today our customers are using EMF, or your customers are using EMF. So what we provide here is quite a simple thing to be compliant. For example, you have an existing flow model. You can just get it on your web application by choosing an existing file, flow, where it is, robot flow. Yes, this one. This one is the one I created with my RCP application. I can just upload it, and it will arrive as a new project in my as a new document in my project. So I'm able to create a new representation, which would be the same one, topography one. And so you see what it looks like. It mostly looks like the RCP one. I have the same capability. For example, I'm able to change the capacity of my GPU. It will be bigger. I support conditional style. As you see, I can change the value of the usage, it's change the color. What I can do also is when you see that when I am changing the value of the GPU, the size is changing, but what is interesting also is we provide an auto layout, so all the time your diagram is looking really great. After that, what could be interesting for you also is that you are not working alone on your project. Usually you have many kind of users at the same time. Here, I can show you 2 different users at the same time working on the same project. The second one will open the same diagram. If I change this on this one, the capacity, for example, you see that it is changing on the both sides at the same moment. The different user can work on their, I can create a new data source on their model at the same time, and it will be just like this, like you have in the Google Doc, for example. Once they finish to work together, what's interesting is that you need to get back, maybe everyone is not yet using this kind of application. You need to get back your model in EMF. So we provide that also. You can just go back to your project list, project model list, and then you can just download it. Okay, I will just save the file. Okay, and open it. To find it, yeah. I can take this file and put it to my RCP application. This one, just for a new sample, for example, and I'm able to open it. And this is exactly a classical EMF model. This is the EMF, the flow one I just created before with my RCP application. So, we have already done lots of work in the OBEO cloud platform, but we have still more to do. As you see, the UX and the UI is not the hand one. For the moment, it's just a preview. We are working on that. You need just to remember the different capabilities you see and not the UX. The capabilities are today, we provide a CRUD auto-rating tool. So as you see in this preview, we support create, read, update, deletes of model elements based on additions through Model Explorer or basic set of properties view. We are compliant with EMF, as you can upload or download your models to the platform. We are working on supporting Sirius tools to be able to define also your own specific tool and not only the new child capability offered by EMF. And next, we will improve the global behavior by supporting undo, redo, direct edit from the diagram. And this will be able, for example, because we are using Sproti, and Sproti with the new 0.7 version providing capabilities for direct edit. So this is quite cool. And we'll provide also a complete set of widgets for the properties view. At the moment, we are just working, we are just providing the text one, but and the checkbox one. Next, we will improve the global behavior by supporting undo, redo, direct edit, and what we will do also for representations. Today we focused on diagrams, but you can already create nodes, container, edges. We support conditional styles, we are our SVG, and we provide an auto layout. We're working on supporting layers. This is already launched, the pin and unpin capability. And we will support also tools and so a palette soon. Next, we will work also on supporting more representations, tables, trees, dashboard, text editors, and we will continuously improve the auto layout. From the collaboration point of view, our backend already supports basic concurrent edition, as you see. We are working on the kind of live visualization collaboration as what you can find when you work on Google Doc. So we're trying to do that Also, this is why the UX will change a little bit. Next, after that, we will provide a kind of one-click share solution to provide a solution to easily share a model or share a diagram with anyone, or just integrate it to any web application, for example, as a wiki. And we aim also to provide a way for you to see your historic of modification and a kind of review system in order that you can collaborate on some representation by annotating them. After that, we are working also on the extensibility. From an extensibility point of view, you already have some capabilities, as you have the possibility to integrate EMF edit, Java services, and we have in mind also to provide a platform that will be extensible, and we will rely on Spring mechanism for that. In the end, if you decide to use the OBEO cloud platform to create your domain-specific tool, you will obtain modeling tool in the web easily based on what you already learned from Sirius. So nothing new, some Java code to do for the web application, but that's it. Your end user will be able to visualize, create, and edit multiple kinds of representations, diagrams, forms, text editor. It will help them to structure their information, as it's still model, and it's still a model-based tooling. So this will help them to keep consistency of their data with what's new is an easy access to the tool by their browser. Everything is there to create quickly engineering applications dedicated to a specific domain. And as it's cloud, it would be easy to deploy, it would be on-premised. Your end user will never have to save a file again, as we have autosave. They can share models with just a live link in the hand. No worry about editing or collaboration, as we have a version control in the hand. Our purpose is also to provide some user permission in order to control and to manage who can view, edit, or yes, add some contribution to the model. So today we are looking for people from the Sirius community to try what we develop. So if you want to try the OBEO cloud platform preview, contact me. So you can follow this link. You will find just a Google form, but I will be the one that will read it, and I will send you back the emails. There is no salesman after that. So I will keep in touch with you to give you soon a preview access of the OBEO cloud platform when it will be ready. We are developing the new cloud platform, but we keep the efforts on the RCP one. This year, for example, we continue to improve the actual Sirius. We work on optional table header. Now you can just decide to does not show the first column. It is now possible to indicate that when you specify your model, your Sirius specification, sorry. And so the optional header will be hidden by default. With Sirius 6.1 also, we provide a new way to contribute some menus on the RCP application. So you are able to add some more actions to existing menu, or to reorganize this with some existing groups or create new groups. We have now also added a new visibility mode. This one is pretty cool. That can be activated from the tab bar exactly as the layer are. In this mode, all the hidden diagram elements are temporarily visible and semi-transparent, and so you can toggle the visibility of an element with just a simple double click. We also continue our work on the ELK integration. We did that for the web application, but it's also available for the RCP one. So what you could expect now is the first public preview of the OBEO cloud platform for December. And so since next year, you will have two flavors for Sirius, the classical RCP one or the web test now. So finally, remember that Sirius is visual. You can create diagrams, table, trees, and even properties views. It is declarative. There is no code generation involved at any time. Everything is interpreted at runtime. And the most important, Sirius is easy. You will get your own cloud or desktop modeling workbench in hours. You can find more about Sirius at EclipseCon. Later today, there is a Sirius use case given by Bosch. This afternoon, there is also a presentation about Capella, which seems to be interesting. It is based, Capella is based on Sirius, and it will allow you to see what kind of engineering tool you can create with Sirius. And at any time, you can visit our No Goodies booth. It's just over there. Why No Goodies? Because has OBEO decided this year to just stop providing plastic-based goodies, we prefer to give this money to a project which will just try to clean the oceans. So if you have some question about that or about, yes, the web tool, just come to see me to discuss. I will be really happy to discuss with you about what we are doing. Thanks. I'm too late for questions. I'm sorry, but yes, I'm here. I will be on the booth just over there, so do not hesitate.